So in this video we'll be solving problems from exercise 1.6 of chapter sets, which is the last exercise of the chapter. So the first question we have, if x and y are two sets such that number of terms in x is 17, number of terms in y is 23, number of terms in x union y is 38, we have to find number of terms in x intersection y. It has been given in the question that number of terms in set x is 17, number of terms in set y is 23, number of terms in x union y is 38. We have to find number of terms in x intersection y. So we have learnt a standard formula where n union x union number of terms in x union y is equal to number of terms in x plus number of terms in y minus number of terms in x intersection y. So we have to just replace it here. So we have 38 is equal to 17 plus 23 minus n x intersection y. So if we bring this side, n number of terms in x intersection y will be 17 plus 23 minus 38, which is nothing but 2. So number of terms in x intersection y is 2. So coming to the second question. So we have, if x and y are two sets such that x union y has 18 elements, x has 8 elements, y has 15 elements, how many elements does x intersection y have? So we have n of x given as 8, n of y given as 15, n of x union y given as 18. We have to find n of x intersection y. So this is same as the previous question with different numbers. So n x union y is n of x plus n of y minus n of x intersection y. So this is 18 is equal to 8 plus 15 minus n. So on solving this we get that n of x intersection 5 is equal to 5. So coming to the third question. So in a group of 400 people, 250 can speak Hindi, 200 can speak English. How many people can speak both Hindi and English? So we have people who can speak Hindi is 2. So we'll take it as set H. So number of people in set H is 250. So number of people who can speak English is 200. So we'll take that as set E. Number of people in set E is 200. So totally we have 400 people. That is nothing but H union E, which is 400 people. So we have to find people who can speak both Hindi and English. So that is nothing but intersection of H and E. So again this is same as previous one, which is n of x or n of H here, sorry, plus n of E minus n of H union E. So nothing but 250 plus 200 minus 400. So we have 50. So 50 people are present who can speak both Hindi and English. Coming to the fourth question. If set S and T are two sets such that S has 21 elements, T has 32, S intersection T has 11, how many elements does S union T have? So we have to find number of terms in S union T, which is n of S plus n of T minus n of S intersection T. In the question is given that n of S is 21, n of T is 32, and n of S intersection T is 11. So on solving this we get 42. So we have 42 elements in total elements, that is S union T. If x and y are two sets such that x has 40 elements, x union y has 60 elements, and x intersection y has 10 elements, how many elements does y have? So we know that x of n union y is n of x plus n of y minus n of x intersection y. So in this question n of y is not given. So n of x union y is given as 60, n of x is given as 40, we don't know n of y, and n of x intersection y is given as 10. So n of y will be 60 plus 10 minus 40, which is nothing but 30. So number of elements in set y will be 30. Coming to the sixth question. So in a group of 70 people, 37 like coffee, 52 like tea. Each person likes at least one of the two drinks. How many people like both coffee and tea? So this is similar to the third question. Number of people who like coffee is equal to 37. Number of people who like tea is equal to 52. Total number of people, that is coffee union tea, is equal to 70 people. We have to find people who like both tea and coffee, that is C intersection T. So n of C intersection T will be n of C plus n of T minus n of C union T, which is 37 plus 52 minus 70, which will give us 19. So the number of people who like both coffee and tea is 19. Seventh question is, in a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? How many like tennis? So we have C union T, which is cricket union tennis, as 65 people. So totally we have 65 people. Number of people who like just cricket is 40. Number of people who like both cricket and tennis, that is C intersection T, is 10. So we have to find how many like tennis and not cricket, and we have to find how many like just tennis. So how many like just tennis is NT. So this can be found easily, and C union T is NC plus NT minus NC intersection T. So we have 65 is equal to 40 plus NT minus NC intersection T, which is nothing but 10. So n of T is 65 plus 10 minus 40. So n of T is 35. So there are 35 people who like tennis, but there's also a question where people who like only tennis and not cricket, which is T minus C, n of T minus C. N of T minus C is given as n of T minus n of C intersection T. So n of T is people who like both cricket and tennis. N of C intersection T is number of people who like both cricket and tennis. We need only people who like tennis, so we have to remove the number of people who like cricket and tennis from number of people who like tennis. So that is nothing but 35 minus 10 equal to 25. So number of people who like only tennis and not cricket is 25, which we get by subtracting number of people who like both cricket and tennis from number of people who like tennis. So we get number of people who like only tennis is 25. Coming to question 8. If a committee has 50 people who speak French, 20 who speak Spanish, 10 who speak both Spanish and French, how many speak at least one of these two languages? So we have a committee where 50 people can speak French, so n of s will take it as 50, and we have 20 people who speak Spanish, so n of s will be equal to 20, number of people who speak Spanish, and there are 10 people who speak both Spanish and French. So we have n of s intersection f as 10 who speak both Spanish and French. So we have to find how many speak at least one of these two languages, that is total number of people present in the committee, that is S union F, which is n of f plus n of s minus n of s intersection f. So we have 50 plus 20 minus 10, which is nothing but 60. So there are totally 60 people present in the committee. So apart from these exercises, there's also miscellaneous exercises present in the chapter. I would highly recommend everyone to go through the miscellaneous examples and try solving the miscellaneous example as miscellaneous exercise as well, since the questions in these exercises are the one similar which will appear in the CET and the mains exams as well. So solving these problems will give you a good idea on how the problems or the concepts they will ask in CET and mains questions.